Let's discuss a question from thermodynamics. You have a reversible heat engine which is exchanging heat with three reservoirs. So this is heat engine. Okay, and the first reservoir is at 1000. It's a source from which it takes the heat, and this heat is about 2000 kilojoules. And then you have another source which is 800 Kelvin, and this it takes. So let's take this 2000 as Q1. It takes Q2 from 800 Kelvin, which is at 1200 kilojoules, and then it rejects heat to reservoir which is at a lower temperature. Basically, it's a sink. Okay, which is at 600 Kelvin. So Q3. So it takes heat Q1 and Q2 from two reservoirs and gives out. Remember that it's a reversible heat engine. Okay, and this fat will be used later. Now the work output, and it does some work obviously. I mean, it's a heat engine, it does some work. So now how do I calculate this? So first, from the energy balance, which can be applied to any engine, whether it's reversible or irreversible, that doesn't matter. Okay, so Q1 is the heat addition, Q2 is the heat addition, minus Q3 is the heat rejection. So that total should go, because it's a cyclic operation of a heat engine, so that should be W. So 2000 plus 1200 minus Q3 is equal to W. So that is nothing but 3200 minus Q3 is equal to W. Okay, so this is, but now I need to know Q3. I mean, for knowing W I need to know Q3. Q3 is something which I don't know, but then the fact that it's a reversible heat engine, we use the Clausius inequality which says that dq by T, normally it should be less than or equal to 0, but for reversible heat engine it is 0. It's nothing but basically the entropy, the change in the entropy, okay, for this heat engine has to be 0. That's the basic idea, change in entropy, because it's a reversible heat engine. So the heat addition, the increase in entropy is Q1 by T from the first side, Q2 by T2 from the second side. Now it is rejecting heat to Q3, so Q3 by T3 is equal to thing. So these heat transfers involve the exchange of entropy, and the sum of the entropy exchange has to be 0 for a reversible heat engine. So Q1 is basically 2000, and that is by T1 is 1000 Kelvin. Here you have to use 1000, the Kelvin, and 1200 by 800. Q3, which we don't know, which we'll get from this equation, is by 600 is equal to 0. So from this I can easily get Q3, and Q3 comes out to be 2100 kilojoules, and then we can get what we want. So once we substitute 2100, W is 1100 kilojoules. So 1100 kilojoules of work is done. So the learning from this problem is that normally we have one source and one sink, so directly you can just do the heat balance, and then in that case also, the fact that Q1 by T1 is equal to Q2 by T2 comes from this entropy change for a reversible engine. So this comes from the change in entropy, which has to be Q1 is the heat addition minus Q2 is the heat rejection is equal to 0. So there also you are basically applying delta S is equal to 0. The change in entropy for the reversible heat engine is 0. So you get that expression Q1 by T1 is equal to Q2 by T2. Now because you have three reservoirs, so you have to just apply for the taking into science consideration, you have to apply for all the three reservoirs. This change in entropy is 0. And then remember that when you have three reservoirs, always you have to use this equation, okay, apart from the energy balance, to get the required quantities. So the answer is 1100 kilojoules. Thank you.